we're going to be talking about Riemann sums, which are named after the German mathematician Bernhard Riemann. The most common application of Riemann sums is approximating the area of functions or lines on a graph. They may also be used to estimate the length of curves and other approximations. The sum is calculated by dividing the region under a curve up into shapes, like rectangles, trapezoids, parabolas, or cubics, that together form a region that is similar to the region being measured, then calculating the area for each of these shapes, and finally adding all of these small areas together. This approach can be used to find a numerical approximation for a definite integral, even if the fundamental theorem of calculus, which you should know, does not make it easy to find a closed-form solution. Alright, Riemann sums continued. Because the region filled by the small shapes is usually not exactly the same shape as the region being measured, the Riemann sum will differ from the area being measured. One can reduce this error by dividing up the region more finely, using smaller and smaller shapes. In class, we studied right and left-hand rectangular approximations as well as midpoint approximations and trapezoidal approximations. Right and left methods make an approximation of the area under a curve using the right and left endpoints of each subinterval. Midpoint Riemann sums make an approximation of the area under the curve using the midpoint of each subinterval. Trapezoidal sums are the average of the left Riemann sum and the right Riemann sum. Before we get into some practice problems, I just wanted to show you what each type of sum looks like on a graph. This first one is a right-hand Riemann sum. As you can see, I drew a bunch of points on the line and made rectangles so that the top right-hand corner lined up with that dot. So you can see here I made the rectangle and lined up the top right-hand corner with that. I did the same here, and for this specific graph, because the rectangles go over your original curve, it's an over approximation. For left-hand Riemann sums, it's pretty much the same, except for rather than lining up your rectangles to make it that the right part of the rectangle is lined up with the dot, you just do it with the left. So for here, you just make it the left corner and draw a rectangle, left corner and draw a rectangle. That's basically how I did it. I feel like that's the easiest way to show someone how to draw Riemann sums like this. And then we have a midpoint Riemann sum, which is pretty much the same as these, except for you do your dots again. I draw all my dots beforehand, and then I make it so that the dot is halfway between the two sides of the rectangle. See, this is my first rectangle, the dot is here. Second rectangle, the dot is here, and then that's my rectangle. So it's basically in the middle of that rectangle. And finally, we have a trapezoidal Riemann sum, which is hard to see because it looks so similar to the curve. But again, I put all of my dots on the line. I'll try to redraw them just so you can see. And then to make trapezoids, I just took two dots here and connected them together like this, and then drew down. And from here to here, it looks very similar to a rectangle. You just connect the two dots, draw down. Here it was more of a slant, so you connect the two dots with a straight line and then draw down. This is clearly the most accurate looking Riemann sum in this situation. You can tell that it is, well, it's extremely hard to tell whether it's an under approximation or an over approximation. It looks very similar to the actual curve. Okay, now we're moving on to some problems that I already did just for the sake of time. I just want to explain to you how I did them, and you can pause the video and look at my work so you can really review that. So all I did here is I read the problem, of course, first, and I realized that I needed to use a left-hand Riemann sum. And I also needed to know the approximation of the total distance traveled by the speedboat from t equals 0.5 to t equals 3, which is from here to here, which means this part doesn't really matter so much in this problem, so I just kind of crossed it out for the sake of the problem. It also says to use 5 subintervals. So to create my subintervals, I like to make them visually, and to make 5 subintervals, I just go like this. 1, 2, 3, 4, 5. And that's just really grouping. I just kind of group them into 5 groups or subintervals. And for this type of a Riemann sum, and for the right-hand Riemann sum as well, for the first part of your problem, you have to take the difference between these two and multiply it. For this one, it would be the number on the left, but for a right-hand Riemann sum, it would be the number on the right. But because this is a left-hand Riemann sum, we would use the left number. So the difference between 1 and 0.5 is 0.5, multiply it by 30. Do this for each of the subintervals and then add all of these up, and you get an answer of 56. Now the second problem is a midpoint Riemann sum. So first, again, I read the problem, and it says to use 3 subintervals. So I use the chart that they gave me, and then I just made subintervals that are 3. So I just made it span 1, 2, 3. So I grouped all of this into just 3 groups. So now, to make my little equation, I take the difference between this number and this number, because it's the two ends of the group that you can see. 40 minus 0 is 40. And then I take the middle number here in this group of the bottom row. I take the middle number here and multiply that by the 40. Then I do the same for these groups. So the difference between 40 and 80 is 40. And the number in the middle on the bottom is 2.1, and I multiply it. I do this again for the third group, and then I do the math there, and I end up with my final answer of 224. And now we have a trapezoidal sum problem. Again, we have a chart, and I have to note that it says to use 4 subintervals. So I do this, 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 and this. I make 4 groups, and then there is an equation that you have to know, or a formula that you have to know for this type of a problem, and it is 1/2 h base 1 plus base 2. So what I did here is I multiplied all of this by 1/2. I just put the 1/2 on the outside. I just put it outside of the whole problem. And then I have to do the height, which is the difference between these two, the difference between the height, which was 1. So I put a 1 there. And then you have to add your 2 bases, which are these values. So I did 100 plus 93 is 193. For the next one, the difference between 5 and 1 is 4. And then 93 plus 70 is 163. I then did that for the other 2 groups, and then I did all that math, multiplied all that by 1/2 because we can't forget about the 1/2 that we put on the outside, and we get a final answer of 605.5. One final problem that's a little bit different. We don't have a chart, but we have a equation. So when I read this, I know that I have to use a left-hand Riemann sum and 4 subintervals. So if it's from 0 to 4, I just wrote from 0 to 4, 0 to 1, 1 to 2, 2 to 3, 3 to 4. And because it's a left-hand Riemann sum, I'm going to circle the numbers on the left, plug them into the equation. Then when I get all those values, I just add them up and then get my final answer. So that's it for this short video on Riemann sums. Thank you for watching.